So dear participants, welcome back with our discussions on temperature transmitters and temperature sensors. We have seen what is the difference between them in our last lecture. We have seen that sensors can generate signals which is of some non-standard format that can be understandable by standard industrial equipments like PLC. In order to transform this non-standard signal into a standard signal and globally accepted signal, we need to use temperature transmitters. You can see here on the left side, we can find this is actually the RTD. This is the protective cover for the sensor material, in which the sensor material is actually there. This you can see is the sensing element in this particular figure, and these are the terminal wires which are there for your electrical connections. Now such type of things are normally not used unless the application is very nominal. In any case of industrial measurement, so far the temperature is concerned, you can find such type of structure. You can see this is the protective head and this is the sheath. Okay, so such type of structures are very common. Whenever you see such type of structure, be sure that there is a factor of temperature measurement. Now in this particular thing, here actually you connect for process measurements. This is the protecting tube. The entire thing is protecting tube, and in this tube actually the sensing element lies. Okay, there are insulating lids which carry these signals from this sensing element to terminals which are present here inside this cap. This is a cap actually. You can unscrew it. And there is one particular terminology you can read here. It is written as cold end termination. This cold end termination is required for thermocouple applications, because in thermocouples you are actually using one hot junction and one cold junction, which is required for operation of the thermocouple. It is made like that, its characteristic is like that. So here the cold end termination is normal there. Now these are related to the sensor. Okay, now you see this is the temperature transmitter. Normally temperature transmitters are installed there inside this head, so therefore these are called head type temperature transmitters. Now you can see that this temperature transmitter is made for PT100. Okay, this is the accuracy of that object. It is written accuracy of this sensor, it is 0.2% of the full scale. Then you have got this voltage 24 volt DC that you have to apply to two terminals. The output is 4 to 20 milliampere and the range is 0 to 50 degree centigrade. Okay, so that you can have the range here, you can have the voltage that is to be applied, and this is the output that you can take out of this. Now how you are to connect, this is normally inscribed over there, and you also have this particular figure. Now you see here, this is terminal 1, this is terminal 2, this is terminal 3, and here from you can have the output. So this is very simple. This is one wire, it will be coming, it will be shorting this. You have to take your PT100 from this to this point. Now you see, while shorting, why you may think why I am to short it, actually you can see the PT100, they have got 3 connections. So now you have to put here the 3 connections likewise. Okay, from here you can get this, you have to apply the supply to 2 points and you will get the output from 2 of the points. Now you can see such type of sensors are also there which are normally HART, HART short of sensors. Okay, this HART is a particular terminology which you will come across in your industrial communication coursework in your next semester. This is a communication protocol actually, which is defined as highway addressable remote transducer. This is a hybrid analog and digital industrial automation open protocol. Open protocol means any manufacturer can use this protocol. The best advantage of this particular protocol is that it can communicate the very standardized 4 to 20 milliampere analog instrumentation current loop, sharing the pair of wires used by analog only host system. So if you have got a host system which is reading continuously from a number of transducers, and such transducers are connected in 4 to 20 milliampere current loop, then this protocol is used. HART is widely used in process and instrumentation systems ranging from small automation application to highly sophisticated process applications. If we take the example of immersion, they say that due to huge installation of the base of 4 to 20 MS systems throughout the world, the HART protocol is one of the most popular industrial protocols today, because you can directly connect your transducer into this protocol. Now HART protocol has made a good transition protocol for users who wishes to use the 4 to 20 milliampere signal current loop throughout, and they want to implement a smart protocol. That means you have the advantage of the smart protocol, as well as you can use this 4 to 20 milliampere standard signal. So all these things are possible with this HART sensors. Now whenever you see such type of platform, you might be 90% sure that this is a hard shot of sensor, because you can see here there are certain buttons through which you can make local changes in program. This is the display and from where the switches may come. Now be sure that even if some particular sensor is having such housing, that may not be HART sensor, that may not be HART enabled sensor, but still in most of the cases it is HART enabled sensors. Now you can see here, this is a protective sheath. You can find, I have shown an exploded figure here. This is the cover. This is actually the plate. This is actually the plate through which the terminals of the sensors are coming out. If you do not apply a head mounted transmitter here, then you can have these terminals screwed. Okay, there are certain screw terminals in which these wires are connected, so that you can have further connections from them through the internally shorted screws. In most of the cases, the head type transmitter is attached here, and then the cap is screwed, so that whatever signal you are getting out of this structure is a standard signal for PLC or PID applications. Now you see here, these are the different type of temperature transmitters. All of them are HART enabled transmitter. You can see this is a DIN rail type transmitter. So if you are having a DIN rail type transmitter, then you need not to put a head transmitter within this protective cover. You can take the wires directly outside from the sensor. You can connect them to this DIN rail 2-wire HART temperature transmitters. This is, you can see, head mount type 2-wire HART temperature transmitter. This is field mounted. This is the field mounted thing, and these are costly, and that you can apply for this temperature measurement applications, remote applications likewise. Now let us talk of thermistors. Thermistors are rather temperature dependent resistors, and they are used in industrial purposes where we need to have overcurrent protection, or we need to protect your device from inrush current. So they are used extensively as inrush current limiters also. Thermistors can be of NTC or PTC type. This NTC means negative temperature coefficient. In such cases, the resistance decreases as the temperature increases. Now this is opposite than metal, because in metals, as the temperature increases, the resistance also increases. But this is the speciality of this NTC type thermistor. Now because of this capability, they are commonly used as inrush current limiters. Okay, because when the current is very high, then the resistance changes in heat is generated. Okay, the heat is generated. When heat is generated, the resistance through this device, that is decreased, and entire current passes through the thermistor. It does not let you the current to pass through the actual instrument. Now again, in the other case, you can use a PTC, where when the temperature increases, the resistance also increases. When the resistance increases, then your current is not allowed to pass, so your device is saved from overcurrent. So you can see these are two opposite applications. In one case, you need to limit the current. You need to limit the current means if the temperature is high. Why the temperature is high of the material? Because large amount of current is passing through it. When large amount of current is passing, then this particular material, it will have low resistance. So then you can use these thermistors as a bypass line. When the temperature will increase, the current will be bypassed, getting bypassed. Now why the current will be bypassed? Because the resistance of the thermistor has gone low now. The current will be choosing that path. So earlier the current which was entering into your device, it will not enter into the device, it will pass through the thermistor. Now in case of positive temperature coefficient thermistors, as the temperature increases, when the temperature will increase, maybe because of high passage of current, the temperature will increase. When the temperature will increase, the resistance will also increase and current will no more be allowed to pass through it. So you have got overcurrent protection, or you can use them in resettable fuses. This you can see, this is NTC. As the temperature increases, the resistance decreases. This is PTC. As the temperature increases, the resistance increases. I am thankful to Real Pulse for these beautiful diagrams. And finally you have thermocouple. Whenever you have got very high temperature measurement application, thermocouples are inevitable. A thermocouple is a device which is comprised of a couple of specific dissimilar metallic wires joined together. So you have two wires of different metals. They are specific metals, and you cannot take anything and you build up your thermocouple. It is not possible. So when they are joined together, they form the sensing point or the junction. Now you may ask me one question, that whether can we take any metal? Yes, you can take any metal, but whether it will be giving you a detectable output or not, that depends on the characteristics of the metal. So therefore in industry there are standards which are used, and you will find the thermocouples commercially available as J-type thermocouple, K-type thermocouple, like that. Now this works on the basis of thermoelectric effect. Thermoelectric effect says that when this junction of two dissimilar wires is placed at different temperatures, then different millivolt signals are generated which can be interpreted as an indication of the temperature. We can see one figure that will make the thing more easy. You can see here that these are the two dissimilar metallic wires. They have connected together and it is applied to some high temperature region. Now there is one cold junction also. This cold junction compensation is one of the most important requirements in case of thermocouples. Now you see, this is the cold junction, and here actually you can measure the voltage. So whenever the temperature increases, the voltage will increase. When the temperature decreases, the voltage will decrease. And accordingly, you can measure the temperature if you properly calibrate the thermocouple. Now this calibration is the headache of the temperature transmitter. You need not to calibrate. You directly couple your temperature transmitter to the thermocouple, and the thermocouple will give you the standard signal which is very much calibrated with the process temperature. Now in comparison to RTDs, the basic advantage of thermocouples is that they are self-powered. They are used for very high temperature applications like furnaces, gas turbines, boilers, etc. Now you see that the main restriction of thermocouples, that is the main shortcoming of thermocouple, is the accuracy. So whenever the application is very precision, then you cannot apply thermocouples. Now another important point is that thermocouples need a reference measurement point which is called the cold junction. When the thermocouples are exposed to extreme environments, then cold junction are mounted near the instrument location. So here the wires are there, they are long wires, and cold junction is connected at the end, normally at the instrument location, from which you can take the measurement. Now you see, based on the range of temperature measurement and sensitivity and some other factors, thermocouples of different nomenclatures are available. They are type E, type J, type K, M, N, T, and so on. In case of type J thermocouple, we actually employ iron constantan type of combination, and we can have a range of -40 degree to 1380 degree Fahrenheit for measurement. This is the measurement window. and the sensitivity is 27.8 microvolt per change in per degree Fahrenheit. Again, the chromal amyl, the chromal alumel material, which is most common in general purpose thermocouple. If you find 100 thermocouples, you find 95 of them are type K, that are using two different alloys. One is chromal and other is alumel, and they offer you a sensitivity of 22.8 microvolt change in per degree Fahrenheit. You see that type K is inexpensive and a wide variety of probes are available commercially. They can measure temperature within a very wide range of operation, that is minus 330 degree Fahrenheit to plus 2460 degree Fahrenheit. And now we will discuss on output devices, and I hope that I will be continuing with this lecture in the next one. Thank you.